EIGRP is going to utilize two different types of neighbors. You're going to have multicast and unicast. Now, the way that you enable EIGRP is still going to be the same in that, let me start with unicast first. If I go into an EIGRP adjacency and I use this neighbor command here, so this would be the command here that I would use. I would say neighbor followed by the destination IP address that I'm actually going to form an adjacency to, followed by that exit interface. So for example, let's say I was on R1. So let's say that this here is my E00 interface. I would say, hey, I want my neighbor 10.1.2.2 to go out of this interface. Now, the important thing here that you need to remember is that this guy is plugged into a switch. So the minute I go in and I type neighbor Ethernet 00, that means that if R2 is talking in unicast, or I'm sorry, in multicast, this adjacency is going to drop and it's not going to work. Now, if I go in and I configure router 3 to be unicast, then that's going to work. But any of these guys that are still talking multicast are going to drop if we're not directly connected. So if we're connected through a switch like this and you decide that you want to enable unicast neighborships using the neighbor command, again, that would be this command right here, what's going to happen is that you are going to drop all of the rest of these guys that are connected on that switch. But the way that I need to enable EIGRP is still going to be the same with the network command. So in other words, if I go in and I type neighbor, 10.1.2.2, let's say to go to router 2 or router 3 or whoever I'm going to form an adjacency with, and I can do that, but if I don't enter the network command and actually enable the process on the interface, it's not going to run, okay? So don't forget that. A lot of people get confused between these two neighbor types and they figure, well, I'm going to go in and I'm going to say I want to, enable this particular neighbor between these two devices, and what they don't realize is that without the network command, it's not going to work. Now, if you're going to have a basic multicast relationship, which is the default, so when you go in and you type the network command, this is going to be the default neighborship that you're going to have in EIGRP. So you go in and you say network, and then maybe that network is going to be 10.1.1.0, and maybe you do 0.0.0.255. So you enable it on all of your 10.1.1.0 interfaces. At that point, EIGRP is going to go into a neighbor discovery process, and it's going to do that by sending these hello packets to 224.0.0.10. And any of the other devices, so let me actually pick a different color here. If we go to the diagram here, you can see that once we enable the multicast adjacencies, that these hellos start going in both directions because we're listening as well as sending traffic on that multicast address. And when we receive the other party's hello, we're going to have an update followed by an acknowledgement, and then we're going to form an adjacency. Whereas the unicast is only going to be a one-to-one relationship where you're only going to be able to form an adjacency with that neighbor. And the minute you go in and you type a neighbor command neighbor command like this, what's going to happen is you're going to kill all the multicast adjacencies that you would have on that particular interface, and you'll have to go in and type those neighbor commands for everybody on that interface. Okay. Now, once this little bullet point here is going to be the same for both. This is really just the multicast process, if you will. Once we actually form an adjacency, we're going to have a full routing table exchange between our neighbors, and then everything after that will be only those routing updates. So if we add a network, we're going to see that in an update. This is going to be the same case here as well. Really, the only difference that we're going to see between multicast and unicast is that we're not going to send these hello packets to 224.0.0.10. We're going to send them unicast to that individual address. So now that we got that out of the way, let's jump into the CLI and let's actually watch it. Okay, gents, so let's get a EIGRP adjacency going across our LAN segment here, maybe between router 2, 3, and maybe we'll even include 4. And we will see how a multicast adjacency works, and then we'll go ahead and we'll switch this guy over to unicast, and we'll watch how essentially that's going to break one of our adjacencies here, whoever we decide not to include. And then I want to finish this video up with actually passive interface, because passive interface plays a different role in between multicast and unicast adjacencies. And I want to be able to show you that. So what we'll do here is, let me actually jot this down. What I want to do is I want to use named mode over on router 2, and we'll use classic on router 3 and router 4. I know I said that backwards and wrote it the other direction, but that's okay. So let's go ahead and let's get named mode configured. So we'll say router EIGRP, and we'll pick a name here. We'll say CCIE. And what I'm going to do here is I'm actually going to say do debug IP packet, because I want to be able to see my multicast packets. You could also do this with an EIGRP debug, and I'll show you that in just one quick second. So we'll say network. And, oops, sorry, I forgot the address family. Address family IPv4 autonomous system, we'll call it 234. And I'm going to say network 10.24.35.2, and we'll enter in all zeros. Now what we should see is we should see a unicast hello, I'm sorry, a multicast hello, go out our Ethernet 02 interface. So it says here that we sourced a multicast hello. Now it doesn't say multicast, but we know it's multicast because the destination here was 224.0.0.10. Now, as I said, you would be able to see the same thing under an EIGRP debug, but it's gonna look a little bit different. You have to know what you're looking for. Let's say do debug EIGRP packets, and we'll say just the hellos. And I'll show you what's not there and should be. So let's say do on all. Now, a lot of people read this and they say, well, there's no information here indicating that it's whether unicast or multicast, and they're actually incorrect because, and I'll tell you why, because right here, if this was a unicast neighborship, they would see the unicast address that we're actually sending these hellos to, okay? So you would see that right here, indicating that this is a unicast hello packet or unicast relationship that we're actually sending this hello to. The absence of this indicates that it is in fact a multicast hello. So again, it doesn't come out and tell you the address. It doesn't tell you, whether it's one or the other. It's really the absence of that neighbor address right in that area. When we go to unicast, I'll show you that's where it is. But you can also again see this information by a debug IP packet. Just again, you want to be careful of the debug IP packet if you have a lot going on. So let's say do show run section router EIGRP. So we have our named mode configuration. Let's head over to, let's say, router 3. We'll say config T, router EIGRP 234. And let's say do debug. Actually, we don't need to do any more debugs for multicast. We'll say network 10.24.35.3. We'll go ahead and enter all zeros. Let's actually get some prefixes in here. We'll say redistribute connected, redistribute topology base, redistribute connected. Do show run section router. What is wrong with my keyboard here? So here's where we're going to say redistribute connected under our topology base. We have our network command. Let's head over to 3. We did that already. Let's say do show IP route EIGRP, and we have routes. Let's include router 4 here. Let's not leave him out. Router EIGRP 234, network 10.24.35.4, and all zeros. Come on, JP. Get on the ball here. Redistribute connected. Do show IP route EIGRP. And so we have routes. We should be able to get from one prefix to another. So router 4 should be able to get to 3. So if I say do ping 192.168. We'll say 3.3, and we source that from our loopback 3 address. We have full reachability. So these guys are able to get to their loopback addresses essentially across our switch here without an issue. Now this is a multicast adjacency. This is a multicast relationship. Now, what happens when we go over to unicast? Okay, so what I'll do here is I'm going to exit out of the topology base, and I'm going to say neighbor, and I'm going to say 10.24.35.3, and I need to give this guy my exit interface. Now, there are other options in here. We'll get into some of them in this video series. For example, looking at over the top, for example, routing. There's some other options that you can enter after the neighbor statement, but here we're just going to go ahead and enter in our exit interface, which I believe is E02. Once I do this, what's going to happen is you're going to see our adjacency drop. So if I say do show IP EIGRP neighbors, I now no longer have any neighbors. Okay. If I go over to 3 and say do show IP EIGRP neighbor, you can see now I only have an adjacency with router 4. I don't have an adjacency with router 2. But now, okay, so I want router 3 to be part of this adjacency between router, with router 2. So I'm going to go ahead and I'm going to say neighbor 10.24.35.2, and my exit interface is going to be E02. I go ahead and hit enter, and what you're going to see happen here is that I'm going to lose router 4. Okay, I should gain router 2, which is the new adjacency that we have, but I'm losing router 4. And this is the drawback to using Unicast, especially when you're connected to a LAN segment or you're connected through a switch, which a lot of times is the case. You start to lose the ability to, Unicast really starts to become a manual intervention. You have to go in and you have to add all of your individual neighbors. So do show IP EIGRP neighbors. We now have an adjacency with router 2, but we've lost router 4. So do show IP route EIGRP. Now we just have router 2 and router 3. If I wanted to form essentially a full mesh, if you will, I would have to go in and I would have to say neighbor 10.24.35.4 E02. I would have to go over to router 4 and I would have to say neighbor 10.24.35.3 exit interface 02, and so on and so on and so on. I would have to go in and I would have to do that over and over and over again to be able to form this full mesh if that's really what I wanted. Now, EIGRP would take care of loop prevention and all that kind of stuff. We don't need to worry about it. So I could say, let's say do show run section router EIGRP. I could say neighbor 10.24.35.4 E02. And did I add that? Let's say do show run section router EIGRP. I did not add router 2, so let's do that. 10.24.35.2 exit interface E02. So we have a full adjacency that came up between router 2 and router 4. So say do show IP EIGRP neighbors. We have a full adjacency there. Let's check 3. Do show IP EIGRP neighbors. We have an adjacency there. Let's go to 2. Do show IP EIGRP neighbors, and we have an adjacency there. So let's say do show run section router EIGRP. Here's the named mode configuration that we would have. So we have the 2 neighbor statements here underneath the AFI, the address family. Okay, and then we have the network statement. Now the thing is that without the network statement, you're not going to have an adjacency. Okay, so what I'm going to do is I'm actually going to leave the Unicast configuration set up on router 2, and what I'm going to do is I'm going to head over to router 3. We'll say do show run section router EIGRP. Just take a quick look at it, and then I'm going to remove it, and we'll just kind of leave it there in the on the screen so we can go back to it. All right. So now once I remove it, we're going to go ahead and re-add it. Okay, so now we're re-adding EIGRP, and all I'm going to do is I'm going to go ahead and enter the neighbor statements. And what you'll see is that I have the neighbor statements, I have the process, do show IP EIGRP neighbors. I don't have any neighbors. If I say do debug, let's say EIGRP hellos, oh, forgot packets. All right, let's debug the hellos. I don't see any hellos. And the reason I don't see any hellos in EIGRP is because I don't actually have the process enabled yet. If I say do on all here and I say do, let's say debug IP packet, what we'll find is that we're receiving inbound hellos. So let's take a look at this real quick. So say do on all. You can see that we're receiving inbound hello packets, and this is the difference again between Unicast and Multicast, is that when we do the debug IP packet, we can see the source as being router 4, we can see the source as being router 2, we can see the destination being directly to us. But what we don't see is we don't see any packets going out. Now what I want to do here is I want to go over to router 2 for a second, and I want to say do debug EIGRP packet, and I want to say hellos, and I want to show you the difference here in a Unicast hello. So let's take a quick look at it. Okay, let's say do on all, and here's what I was saying before, that you should see this neighbor. Okay, so when we're in a Unicast configuration, this is exactly what you're going to see in your hello packet that's going out. In a multicast configuration, this is actually the received, so ignore that. This is what you'll see here. In a multicast configuration, this will not be here. In a Unicast configuration, you'll see the exact neighbor that you're sending those hellos to. So let's go ahead and let's actually fix this. So all we need to do, if I say do show run section router EIGRP, all I need to do here on router 3 is I need to enable the process on the network interface where I want to actually send these hellos out. So this can still be your regular /32. Let's say do debug EIGRP packet, and we'll say hellos, and we'll see these hellos going out. We already formed an adjacency, so you know that the hellos actually went out. And now you can see that we're sending these hello packets out those particular interfaces. So these are kind of those differences between the unicast and the multicast, the things that you have to be careful of, especially when you're going to configure this on a LAN segment. It's not the hardest thing in the world, but you have to be careful of it. Now what I want to do is I want to actually back out the neighbor statements. We're going to put them back in a moment. Let's say do show run section router EIGRP. And I want to take a look at passive interface here for a second. We're going to run a packet capture as well. So we're going to drop the neighbor statements. We should be able to form a multicast adjacency. Okay, that came back up, that came back up, and that came back up. Okay, so suppose that I want on router 2, in a multicast configuration, I want 10.1.2.0 to appear in the routing table of, router 3 and 4 as an internal address. I could go in and I could say redistribute connected if I wanted to, right? I could certainly do that. But what if I want to use the network command? I could go in and I could say network, and I could say 10.1.2.2, and I could enter in all zeros. And now at this point, if I go over to router 3 and say do show IP route EIGRP, I should see the 10.1.2.0 coming in as an internal route, and I do. The problem is that if I say do debug EIGRP packet and I say hello, what I'm going to see is hello packets now going out the Ethernet 00 interface. And there they are, sending hellos out E00, and I don't want that. So passive interface here can help me. So I'm going to go into address family interface, and we'll say Ethernet 00, and I'm going to say passive interface. Okay. Now at this point, if I say do debug EIGRP packet, and I say just the hellos, I'm not going to see the hellos going out Ethernet 00. So that's one way to do this in named mode. You could also go into the address family default. So I could say address family interface default, and I could passive interface out everything, and then just no passive out the other interfaces. So let's say do show run, let's say do on all actually first, and let's say do show run section router EIGRP. And so that would be under, instead of passive interface here under E00, it would say AF interface default. Okay, so again, it would be address family interface and then the default command, and then it would be passive interface here, and it would be basically the same configuration. But in my case here, I only want a passive interface out one interface, and so no need for extra configuration. So now, if I say do show IP route EIGRP, I still see this guy as an internal route, but I'm no longer sending out these multicast hellos out of that particular interface, okay? But what about in a unicast configuration, okay? Very interesting. There's really no reason why I would see you to do this unless something, you were taking some exam and something led you down the rabbit hole to do this. You just have to be careful with the wording. When you run a unicast configuration, if you have a neighbor statement on an interface that is also passive interfaced, you will see hello packets. So the passive interface only blocks the multicast hellos. It does not block the unicast hellos. And let me show you that here. We're not going to form an adjacency, but let me actually show you how this happens. So let's say do show run section router EIGRP. And I'm going to go ahead and I'm going to say network 10.3.5.3, and I'm going to enter all zeros. So in theory, we should see this network here as an internal route on router 2. Let's say do show IP route EIGRP. And what was that? That was 10.3.5.0. So here it is, and we see it as an internal route, right? Now what I'm going to do is I'm going to go ahead and I'm going to passive interface out this interface E00. So here we're going to passive interface. Let's say do debug EIGRP packet, and we're going to say just the hello packets. And I should not see a hello packet out the E00. It should only be E02. So sending out E02, sending out E02. We're receiving both in. So we should only see the sending out of E02. We should never see the sending of E00. But watch what happens once I enter the neighbor statement. If I say neighbor 10.3.5.5 and I say Ethernet 00, what we're going to see is we're going to see sending hello packets out Ethernet 00. So we'll say do on all. Let's give this a minute. And you can see we sent quite a bit. So here we sent a hello packet out to E00. We sent a hello packet out E00 here. So we started sending out these hello packets even though EIGRP, even though we had passive interfaced this out. The minute you say neighbor whatever, you're going to start seeing these unicast hello packets actually being transmitted. So don't be deceived by the fact that the passive interface blocks those hello packets. The passive interface in EIGRP is only going to prevent the multicast hello packets. It's not going to prevent the unicast hello packets. However, passive interface will prevent the adjacency from ever forming. So if I go over to router 5 here and I say config T, router EIGRP 235, and I say network 10.3.5.5, all zeros, and I say neighbor 10.3.5, come on, 10.3.5, killing me here, .3, E00, do show run section router EIGRP, do ping, let me just make sure, 10.3. So you can see here that we have a new adjacency, right? So let's say do show IP route EIGRP, and I don't get anything, right? So here, let's say do show IP EIGRP neighbors, and you can see that on router 3, we don't actually have a neighborship that's registered with router 5, but router 5 seems to think he does. If I say do show IP EIGRP neighbor, you can see that router 5 has a queue count that's going up, and he thinks that he's a neighbor with router 5. So the passive interface is going to prevent the neighborship. It's not going to prevent the hello packets from going out in a unicast configuration. If I go in and say no passive Ethernet E00, in theory this adjacency should come right up on both sides and we're hunky-dory. So don't be confused there, guys. These are the differences between the EIGRP neighborship types.